Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. This is video number 16 in our video series regarding the ethical use of AI research. In today's video, we're going to look at correlation and regression as against the normal practice, whereby in the case of correlation, we normally just report the R value and we maybe say the relationship is strong or weak, negative or positive, then we just leave it as it is. Then in the case of the regression, what we normally do is we develop the model, then we give the value of the R square to say that the model is strong because the R square value is this, that it has captured about this of the variability. So, but we can go beyond this actually, we can formulate the hypothesis to see whether the relationship, the positive relationship that we are saying, the negative relationship that we are reporting, it is statistically significant or not. And also we can now see that where the value of our R square, which shows the effect of the what of the independent variable on the dependent variable, is it statistically significant or not. So we can only do this through the what hypothesis testing. So that means we can marry the two together. So you introduce the hypothesis into the correlation and the regression. Then you now say that it's statistically significant or not. So let us start with the correlation. So normally, as we have said, correlation is just if you want to see a relationship between two variables, then you use the correlation. So if the data are normally distributed and they are continuous, so we normally use the Bayesian correlation. If the data are not normally distributed and maybe sometimes ordinal, so we can use the Spearman correlation. In whichever method we adopt, we normally have the coefficient, the correlation coefficient represented as R. So when the value of this R is 0, it shows that no relationship exists. And when the value of R is from 0 to 1, 0 to 1, so it shows a positive relationship. When the value of the R is from minus 1 to 0, it shows a negative relationship. And this positive relationship simply means that, let's say this is accident and speed. So when vehicles are moving at 40 kilometers per hour, so two accidents were recorded. Let's say when the vehicle are moving at 90 kilometers per hour, 9 accidents were recorded. So assuming if our R is 0, so we now say no relationship between the speed of the vehicle and the number of accidents that are normally happening. So let's say if our R is 0 to 1, that means a positive relationship, which from 0 to 0.5 we consider it weak, and from 0.5 to 1 it is being considered as a strong positive. So when it is a positive, it shows that an increase in speed will result to an increase in what? In the number of the accidents. So let's assume our R is from minus 1 to 0, so which is from minus 1 to minus 0.5 is being considered as a strong negative correlation. Then from minus 0.5 to 0 is being considered as weak negative correlation. So in this case, what this means is that an increase in the speed will result to the decrease in the number of the accidents, which is a inverse proportion. So before we continue, let us maybe demonstrate this, then we can now be explaining as we are going. So let's go to the data, then the data analysis, then we come to the correlation. Then we choose our variables including the what? Including the headings. Then we choose where our output is supposed to be. Then because we are selecting the heading, so we check this. Then you now click on OK. So as you can now see, the Excel output just gave us a kind of the R value of 0.849. So which is shows a strong positive correlation. But however, this does not give us any of the parameters that we can use to test the hypothesis. Like for instance, the t value, the p value, the f value, and the rest. Nothing has been given by the output of this particular Excel. But if you want, you can calculate the t value from the value of the r given. Then you now go to the table and find the critical t, then you compare it. The calculation of the t value is actually simple. It's not the empirical equation is not that difficult to deal with. So all what you just need to do, you multiply this your r by the square root. So the square root of it. So just double click it. So you now open bracket, or you can just let me just okay. Let me open bracket. So you see our sample are 10 in number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the formula says n minus 2. So that means we're going to deduct 2 out of our total sample, which is 8. So we can say 8, then close the bracket. So we can say divide by. So here we open another bracket. The formula say 1, then minus this r square. So we square the r. So you close this and close the bracket, then you press enter. So you see here your t calculated value is 4.55. So you go to the table, the t table, with your df degree of freedom, which is 10 minus 2, then 0.05 then you now obtain the critical value, then you compare that with this. And if this value is greater than the critical obtained from the table, you now reject the null hypothesis. If this value is less than the value obtained from the table, then you accept the null hypothesis. But what will our null hypothesis be? So our null hypothesis will assume no relationship. And we say if there is no relationship, our R will be equate to what? To 0. So our alternative hypothesis, which is the H1, will assume that there is a relationship and therefore our R is not equal to 0. Okay, let us try this and see whether we can have the SPSS. So this is just the same data that we have this thing. So we go to the analyze, then we go to the correlate, then variate. So you take all of this to the variable distance. So you click on what? Okay. So you can now see the output of the SPSS gave us the what? The R value of 0.849. It also gave the what? The p value for the two tail given as 0.02. So and this 0.02 is less than 0.05. So you see this is statistically significant. So we're going to reject the null hypothesis that says no relationship, and we're going to what? Accept the alternative hypothesis that says there is a relationship. So if we are interpreting this, we will now say that there is a strong positive correlation between speed and accident. Then you now write R, open bracket, put the value of 0.49, then close the bracket. And you can now say that the relationship is also statistically significant. Then you now open the bracket, you now say P less than P of 0.02 less than 0.05. So by here you have tested the hypothesis and you have established that this relationship is statistically significant. So let us see how we can also use the hypothesis when it comes to the regression. So the difference between uh, the correlation and the regression and the regression is that the correlation just try to establish the relationship between the variables, while the regression try to establish the relationship between dependent and independent variables. And this dependent variable is usually always one, and the independent variable could be more than one. So, and also we are trying to see the effect of the independent variable on the what? On the dependent variable. So at the end of the day, we can now come up with a model that can predict the dependent variables from the independent variable using the coefficient of the independent variable, which is normally called as tangent, and also the or sometimes the slope. Then we have the intercept, which is the constant. Okay, let us do that, then we'll be explaining as we are going. So here we're going to go to the data analysis, then to the regression. Then we can now say okay. So we choose our y value. So our y value is our dependent value, which is the accident in this case. So you now select the accident. Then the x values are the what? Are the independent, which are the what? The speed of the vehicle. So you now select them. So we can now choose where we want this to be. So let me just choose anywhere. So let's just choose maybe here. So we can now say okay. It's replacing some parameters. So we now say okay. Let me just change this. Let me just use here. So I can now say okay. Oh, I need to check this level because I have included the heading. So this is our output. So let's see what we have. So you see from this output, we have the R, which is 0.84 this. Then we have the R square, which is 0.72. So what this R square is saying is that 72% of the variation in the dependent variable, which is the accident, has been explained by the what? By the independent variable, which is the speed, which shows that the speed has effect on the what? On the number of the accident that are normally happening. So this one you can now come up with the predictive equation, and the predictive equation is normally in the form of we say y is equals to c then plus let's say bx. So you see this our c is the intercept, which is the constant, then the b is the coefficient of the independent variable. So from this output, our c, which is the intercept, is minus 2.48. So I can now say y is equals to minus 2.489, then plus, then my tangent, which is the slope, is 0.117, then x. So that means I can now predict the number of the accident that may likely happen when a vehicle is moving when the vehicles are moving at a particular speed. Like for instance, and the value of this R square shows the strength of the predictability of this particular model, because this R square shows that 72% of the variation in the independent variable have been captured by the in the dependent variable have been captured by the independent variable. So the higher the R square value, the better the predictive power of the model that you have developed. Okay, let us just try to demonstrate that. So let me just use any of the speed using this. So I can now say minus 2, say 0.489, then I can say plus 0.117, then I will multiply it by any of the speed. So let me just say this. So you see here it is saying that as a speed of 40 from the model, the number of the accident is 2.191, which is almost similar to this. Had it been this R square value approaches 1, maybe around 96, 98, so this value will be somehow perfectly this. So let us repeat the same thing and see what it will give us. So the same thing, minus 2.489, then let's say plus 0.117. So now we can multiply it by, let me take the last one, which is 90. So you can now see that it says at the speed of 90, the number of the accident is 8. In the actual data, it is what? It is 9. That explains the remaining variation that were not captured in the model. So also you can formulate the hypothesis. But in this particular case, if you are formulating the hypothesis, we normally formulate the hypothesis with respect to the B. because this particular b is the coefficient of the what of the independent variable. Had it been everything remain constant, it shows that y equals to 0.07 times the what times the independent factor. So here you assume that your b is 0. That will now be your what? Your null hypothesis. Null hypothesis. That is no effect. So what you are saying is that the speed has no effect on the what? On the accident. Then the alternative will now be the speed has what effect on the accident. So to obtain or to let's say to accept or to reject the hypothesis, you go with the significant f value if you want, which is the p value. You see here 0.01873, which is less than 0.05. So in this, I'm going to reject my null hypothesis that says that the speed has no effect on the number of the accident. So I will now go with the alternative that says that the speed affects the what? The number of the accident. If you like, you can use the p table. So similarly, you're going to have the same output when you utilize the SPSS. So let's go to the regression, then we'll go to the linear. So the accident will go to the dependent and the speed will go to the independent. Then you now click on what? On OK. So you're going to have the same thing. So you can see the coefficient here minus 2.489. Then the constant, then the slope is given as minus 0.118. So the same thing. So here these are the significant value, which is the same thing as 0.02. So you can now say this is statistically significant. So in a situation whereby maybe you don't want to use all this, you want to utilize the AI. So let's see whether the AI can do that for us. So I will just copy this. So let me see whether I have a connection. Okay. So now I'll go to the ChatGPT. Let me say perform a regression, or let's say correlation, and regression. Let's say on this data. Let's say also test the hypothesis. So here you need to, for clarity, you need to specify which of the variables are dependent and which of the variables are independent. So let's say let the accident, let the accident be what? Be the dependent variable, and the what? And the speed be the what? The independent. Let's say independent variables. So I can now say report the R and the, let's say R square. So let's say and perform the hypothesis. Perform the hypothesis for both. So just try to explain what you need, what you want this thing to do for you. So if you can do that, so it can understand what you are really trying to do, what you want it to do, so and it will give you the exact answers. So let me just test it here as well. Okay. So let's wait and see what the output will be. So let me check the DeepSeek. So the chat GPT is not going. So let me just, should I open another one? New chat. Let me just close it and maybe open it again. It's not responding, so wait for it to respond and let me just paste. Okay, let me paste. So the chat GPT is not responding. Let's see the output of the, it has finished. Okay, so it has done the correlation. It has calculated the value of the R to be this. So which is the same thing with what we obtained using the SPSS and this, because this is the value of the R. Then it interprets this. So this indicates a strong positive linear relationship between speed and accident. So it does the regression analysis. It has given the tangent to be 0.117 and the watch and the intercept to be minus 2.8, which is the same thing with what we have obtained using this thing. You can see these values. So uh, it calculated the R squared to be 0.721, which is also the same thing with what we have obtained, 0.721. Then it now tests the hypothesis for both the correlation and the regression. For the correlation, it assumes this, which is the null, and this is the alternative. So this, you see the t statistic we calculated of 4.55. You remember when we calculated the t value manually, this is it, 4.55. So you see it has accurately calculated the t. So and it has given the t critical from the table as 2.306. So you see this 4.55 is greater than 2.306. So that means you are rejecting the null hypothesis because the t calculated is greater than the t obtained from the table. So it has concluded that since the t of this is greater than this, so we reject the null hypothesis. There is a significant correlation between speed and accident. Then it went ahead to calculate to do the hypothesis for the regression, which I said we normally do it with respect to the slope. So it assumes the slope is 0 and the slope is not equal to 0. So it also uses the t to make its own decision while we use the p-value. But at the end of the day, we're going to have the same thing. So it rejects the null hypothesis, whereby speed is significant predictor of the accident. That means it has much effect on the accident. Then it gives everything. Then it makes the final conclusion. So you see the 72.1% of the R square that we are saying. It says the regression model explains 72.1% of the variation in the accident, which we have explained earlier. Then so the ChatGPT have not responded. So I think the DeepSeek has done that for us as well. So maybe you can try that of the ChatGPT, and you can now and this importantly, what you just need to do is to get the basic. When you have the basic, you can utilize all these tools. They are free. Like the SPSS, if you are not using the crack version, actually you need to buy it, and sometimes you need to spend much time learning it. But once you have the basic, you can be able to utilize all these tools. They are free. So, assalamu alaikum.